Section 1.7 is called the chain rule, and this is going to be the last derivative rule that we learned for a while. The chain rule is basically supposed to handle examples and problems where you have bases containing x's raised to a ridiculously large power. So something like this basically. You have a base containing a lot of x's raised to one common exponent on the outside. So the rule is called the chain rule, but it's also known as the extended power rule. So you'll hear me using both terms to describe it. Sometimes I'll say chain rule, sometimes I'll say the extended power rule. And the way that the rule works is described right here in the middle of the page. It basically says, do the same thing that we've done previously, bring the power to the front and then subtract 1. That's the first portion. Once you do that, take the derivative of the inside part and put it next, and then multiply the two things with one another. So this is the reason why sometimes I'll say derivative of the outside, derivative of the inside. So when I say derivative of the outside, I'm saying slide the 3 to the front and then subtract 1 from the 3, turn it into a 2. That's going to be the outside part. And once you finish doing that, copy the x squared minus 2x in the middle and then find the derivative of it and put it on the side, and you'll basically be done with the problem. That's how the chain rule or the extended power rule is going to work. So let me demonstrate with example number 1. So the function f of x in this case is x squared minus 2x to the power of 3. Since there's a lot of x's on the inside and there's a power of 3 on the outside, we are going to need the extended power rule, also known as the chain rule, for this particular question. So the difference between the chain rule or the extended power rule and the regular power rule is that the regular power rule usually has one letter base, like an x or a t or whatever, raised to a power. The problem here has x squared minus 2x, so the base has multiple x's raised to a common power. So we need the chain rule, not the power rule. So again, the way it's going to work is the derivative, which is labeled f prime of x, is going to be like this. First, slide the 3 to the front. So you're going to end up with 3 in front. And then write down the x squared minus 2x. And then put the power 2 in the exponent. So instead of 3, now the exponent is 2. So slide the 3 to the front, and then subtract 1 from the exponent. That pretty much is half the question. The second half, the question, comes from the fact that you have to now find the derivative of the inside. What is the derivative of x squared minus 2x? The derivative of x squared minus 2x is going to be 2x minus 2. Put that at the end, and you're now completely done. So this is the derivative of the inside, derivative of the inside part. And you're done. That's the end of the question. Please be careful not to put equal right here and then write down the answer right next to the original function. Remember, you're doing the derivative. The derivative is different than the function. That's why we have to start on a new line and put f apostrophe x, because this is the derivative, not the original function. So let's demonstrate again one more time with the second example. So in this case, the function f of x is equal to 4x squared plus 3x minus 1, all to the power of 3/4. So what would the derivative be? So again, I'm going to identify that this is a chain rule by noticing how there are a lot of x's in the base and they all share a common exponent. So the rule says, bring that exponent all the way to the front. And once you do that, you end up with the 3/4 in front. It's going to be a massive constant. Then don't touch the base, just copy it over. Once you finish copying it over, take the old power and subtract 1. So the old power, the old power was 3/4, subtract 1, and you get negative 1/4. That is your new exponent. Once you're finished, you multiply by the derivative of the inside part. So your base, whatever that was, take the derivative and write it next. So derivative of 4x squared is 8x. Derivative of 3x is 3. Derivative of 1 is nothing. That's it. So again, that represents the derivative of the base, or the inside part, basically. And you're pretty much done. That's the end of the question. So this would be a good spot for you to pause the video and try to do the next two problems, and I'll give you the answers in a few minutes, or a few seconds rather. So give yourself some time here to pause this and try them out. See if you learned the chain rule. So again, the f of x in this problem needs the chain rule. So the f prime of x will be, again, the same style as before. Take the 1/2 and bring it to the front, and that's how you get the 1/2. Then subtract 1 from the original exponent. The original exponent used to be 1/2. If you take away 1, you get negative 1/2. That negative 1/2 goes now in the power. And once you finish doing everything, you find the derivative of the inside part. And the derivative of the inside in this case is going to be the derivative of x cubed minus 2, which is 3x squared. Now, oftentimes people like to rewrite this expression, so we can rewrite it in a few different ways. First of all, negative exponents can be placed on the denominator and be turned into positive exponents. So x cubed minus 2 to the power of negative 1/2 could be now on the denominator with the positive 1/2. The 1/2 that was in front, 2 goes on the bottom, and the 1 stays on top. And 1 gets multiplied with the 3x squared because it has a positive exponent. It stays on the numerator. And by the way, 1 times 3 is really just simply 3, so we can just get rid of the 1. So this is another way of writing down the answer that's a little bit more cleaned up, and is going to be useful later on in the semester when we're doing more with the problems. All right, so try part 4, and I'll give you the answer in the next video.